I want to do a video on the easiest way to create a container for a Go project. So in some of my other videos, you might see me using a multi-stage build, where I build binary in one step and then copy it into the static image. But there is an easier way, and I want to talk about that today. It's called Co or KO, and the easiest way to show you is just by jumping straight to the terminal. So I have a simple project here. It is a Go project, but there's no container build here. But I do have KO installed. I installed this via just brew install KO. That's all I've done so far. Now, I want to build a simple container for this Go project. All I need to type is go build -l. And that's it. It's now built a container for me that contains the Go project that was in this repository. And there you go. That's it running. So that's really, really cool. Within a few seconds, we have a Docker container for our project building and running. Note that there's no Docker file, there's no config at the minute. That's how easy it is just to get started with KO. There was clearly a flag that I passed, so I did pass -l. And it turns out that means build a local image. By default, if I leave that out, it will tell me this KO Docker repo variable isn't set. So what it's actually saying is I want to build a container image and push it to a registry. I don't know where to push it. We can just tell it. So this is my repo on the Docker Hub. And boom, we've suddenly built an image and pushed it to the Docker Hub. I know it's also pushed an SBOM, but it's only built for the Linux AMD64 platform, which in this case isn't great because I'm actually on a Mac and I want to build for ARM64. So at this point, you probably normally create a config file, which in this case is .ko.yaml. For the purpose of this video, I'm just going to show you with passing flags. So if I do --platform, then give it Linux ARM64 and Linux AMD64, it's going to build images for both platforms. And that's it. And it's also published our SBOMs. And one of the interesting things here is I did use my Docker credentials to log into Docker Hub and upload it. But I could have used a different repo. And KO doesn't require Docker at all. So you can run it in CI/CD and build your Go project without needing to install Docker and run Docker build, etc. So it can remove quite a large dependency there as well. Even nicer is if you use, say you're on GitHub Action, you can use the GitHub token to push to GHCR, and then you don't need to worry about usernames and passwords and so on. So that's a really nice way to do it. Another thing that's worth looking at, if we go back to the image that we built locally, and we run Docker images on this image, you see it's only 23.6 megabytes, which is interesting. And if you look at how it was built, or the config for it, you'll see a few sort of Chainguard things there. And that's because the base image that it's using is a Chainguard static image. So it's basically built static binary and put it on top of the Chainguard static image. You can configure the base image. So say you need your own certificates or another dependency in there, that's no problem at all. But the Chainguard static image is pretty good for most simple Go binaries. There's a few more features that are probably worth mentioning. So there's create and delete, which actually help you work with Kubernetes manifests. And there's also some integrations to help you load your images into Kind, which tends to be a bit of a pain. So that's really nice as well. It's also worth pointing out that Co is a CNCF sandbox project. So it's fully supported by the company and has a wide uptake. It's not going anywhere. It's really a pretty great way to build your own Go images into containers. So that's all I want to talk about. Please do give it a try and let me know how you get on. Oh, one final thing. Why is it called KO or Co? It turns out that two of the authors, Jason Hall and John Johnson, used to play Kickoff 2 on the Amiga, and it was their favourite game ever. So they named it after that.